Understanding K-nearest neighbor model, KNN. K-nearest neighbor model is a supervised machine learning algorithm based on supervised learning technique. It stores all available cases and classifies a data point on how its neighbors are classified. It is actually used to solve both classification and regression problems to estimate the possibility of a new data to become a member of a specific data group that is much similar to the new data. The KNN algorithm assumes that similar things exist in close proximity. That is, data points will be assigned a value that closely matches to the points in the training set. It blindly follows the saying, "Birds of the same feather flock together." It is also called a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set, and at the time of classification, it performs an action on the data set. The most suitable programming language for this algorithm is R and Python. The steps of KNN algorithm are: Step 1. Input the unsorted data set. Step 2. Choose the value of k integer, the nearest data points. Step 3. For each point in the test data. A. Calculate the distance between test data and each row of training data by using Euclidean method, Manhattan method, Minkowski method, etc. Sort them in ascending order with corresponding trained data. From this sorted list, select the top k rows. Find the most frequent class from then chosen k rows. This will be your predicted class. Let us consider that we have a dataset containing oranges and apples in a box. First of all, we will create a plot using the oranges and apples in a box. Now, whenever a new fruit is added to the box with specific features, we will choose a value of k. Let us take 3 as the value of k. Next, we will find the distance of the nearest 3 values, and the one having the least distance will have more probability to arrange the new fruit in that category. Pink dot is equal to orange. Orange dot is equal to apple. X is equal to value to be predicted. In the first graph, the value of k is 1, which means that we are taking only one nearest neighbor into consideration. The nearest value to x is a orange, and hence the one nearest neighbor algorithm predicts that the fruit is apple. 1. Nearest neighbor. In the second graph, the value of k is 2. Taking 2 nearest nodes to x into consideration, we see that one is apple while the other one is orange. This makes it difficult for the machine to make any predictions based on the nearest neighbor, and hence the machine is not able to give any prediction. 2. Nearest neighbor. In the third graph, the value of k becomes 3. Here 3 nearest nodes to x are chosen, out of which 2 are pink and 1 is orange. On the basis of this, the model is able to predict that the fruit is orange. 3. Nearest neighbor. How to choose the value of k? K is a positive integer. K is selected from the database closest to the new sample. K such as k is equal to 1 or k is equal to 2 will be low, and your prediction is less stable and have outliers in the model. Large values for k are better for the accuracy of the prediction. If we push the value of k too far, then we might face an increasing number of errors. Some important features of KNN are: the KNN prediction model uses the concept of new data surrounding by neighboring data set to determine its category. Similar data points are placed close to each other. Uses the properties of the majority of the nearest points to decide the classification of the new data added to the data set. Applications of KNN. Some of the applications of KNN are: recommendation systems. Companies like Amazon or Netflix use KNN when recommending your favorite show to watch on Netflix or your favorite dress to shop from Amazon. They gather data on the basis of the frequently watched show or shopping done on their website and apply KNN. The companies will input your available customer data and compare that to the other customers who have purchased similar dresses or have watched similar movies and will show the rating and recommendation. Credit card fraud detection. By using the outlier value in KNN algorithm, the system can easily predict the possible frauds in credit card systems. Banking and financial systems. It is used to predict the credibility of a customer, whether he is a prospective customer to sanction loan and will not add up to the bad debt of the bank's account. Voting systems. With the help of KNN algorithms, we can classify a potential voter into various categories and predicting the result of the voting. Advantages of KNN algorithm. Advantages of KNN algorithm are: it is simple to understand and implement. It is very versatile for regression and classification. Adding new data to the dataset does not require retraining a model. It gives high accuracy using simple supervised learning techniques. It is very useful for nonlinear data. It is more effective for large training data. Disadvantages of KNN algorithm. Some of the disadvantages of KNN algorithm are: accuracy of the algorithm depends on the quality of the data. The cost of predicting the k nearest neighbors is very high. Not suitable for data with many features or parameters. Occupies a lot of memory space as it stores a lot of training data needed for smooth functioning of the algorithm.